Look inside any modern cyber-physical system, like an autonomous vehicle. You are seeing a deeply intertwined, highly complex environment where mechanical parts, software code, and artificial intelligence operate as a single unit. Building these products requires managing an immense amount of complexity. This diagram outlines the specific elements driving that complexity in modern manufacturing. The left side highlights technical trends that engineers now have to juggle simultaneously, from the Internet of Things to robust data security protocols and heavy reliance on cloud computing. Yet, despite exactly how advanced these complex products have become, the way we manage their design is stuck in the past. We are still trying to build smart machines using thousands of disconnected, static documents. Relying on scattered files isolates engineering teams from one another. If a business executive updates a core system requirement, the mechanical and software teams might not realize it until they physically try to integrate their separate parts. Attempting to build modern cyber-physical systems with document-centric methods creates massive blind spots. It guarantees technical debt, forces costly rework, and pushes back launch dates. Engineering has hit a wall like this before. In the 1990s, the industry reached the limits of physical design. We conceptualized complex machines using rooms full of flat, disconnected 2D drawings. To keep building significantly better products, we had to abandon paper entirely and shift into fully unified 3D CAD environments. Today's disconnected spreadsheets and text requirements are the equivalent of yesterday's flat paper drawings. We need a similar evolutionary leap to keep moving forward. To survive the complexity of modern engineering, we have to move beyond modeling physical shapes. We have to start modeling the invisible relationships, logic, and data flowing between them. That leap is Model-Based Systems Engineering, or MBSE. MBSE defines a system's behaviors, operating requirements, and logical architecture within a specialized modeling environment. This chart illustrates MBSE in practice. It creates a digital thread hub, connecting every enterprise discipline into one cohesive source of truth. Because domains are digitally linked, an update in one department instantly propagates to others. Mechanical constraint changes immediately update software parameters. MBSE acts as the central nervous system for an enterprise. It forces siloed departments to synchronize and operate as one cohesive organism. Every product development cycle is split into two halves, identifying exactly what the customer needs and then figuring out how to actually build it. This framework details the split. The left column is the problem space, establishing business goals and customer needs. The right is the solution space, where engineers design physical parts. Crucially, MBSE mathematically binds the abstract problem space directly to the tangible solution space. By thoroughly validating the exact problem within a living model early on, companies avoid spending millions of dollars perfectly executing the wrong solution. Mapping these precise data relationships enables a suite of advanced engineering capabilities that static documents could never support. A true digital twin requires feeding real-world field data back into the original system model to predict failures. This same model enables variability management, easily spawning thousands of specific product configurations from a single source of truth. These concepts are the concrete mechanical capabilities required to iterate faster and cheaper than the competition. Achieving this level of agility requires a massive organizational effort. You cannot reach it merely by purchasing a new software suite. This structural diagram shows that a successful MBSE capability must be balanced on top of four key contextual factors: the business strategy, the technical architecture, internal processes, and the structure of the organization. True transformation requires political, technical, and executive leadership to align and mandate a cultural shift away from legacy documents. This centralized model serves as the authoritative source of truth for the entire enterprise. It allows leaders to look past departmental silos and see exactly how a strategic decision impacts the actual engineering baseline in real time. To survive the disruptive changes of the digital future, adopting MBSE is a baseline requirement to avoid being buried by your own product complexity.